Hello students, in first session we have learned probability, conditional probability. In the continuation of that, in today's session we will learn very important rule of multiplication, that is multiplication rule of probability. So, and after that we will learn independent events. So two things we have to learn in this for this exercise 13.2. So what is multiplication rule? Suppose there are two events E and F associated with a sample space S. Then the set E intersection F. You know this is the event. It means both the event E and F occur simultaneously. So for this we represent E intersection F by EF in short. So we can apply this symbol also. So by conditional probability we have formula P E of F is equal to P E intersection F divided by probability F, provided probability of F cannot be 0, not equal to 0. By cross multiplication, probability of E intersection F is equal to probability of F into probability of E of the F. So we can say probability of E intersection F is equal to probability of F into probability of E when F has already occurred. In the similar way, we can write this also, probability of F of the E is equal to probability of, this will not change, E intersection F divided by probability of E. Here probability of E cannot be 0. Here also if you multiply this probability of E intersection F, that can be written as probability of EF. EF is equal to probability of what? Probability of E into probability of F when E has already occurred. So this is the formula for multiplication of two probability. This is called multiplication rule for two events. Now for three events, E, F and G. Probability of E intersection F intersection G is equal to probability of E into probability of F when E has already occurred into probability of G when E and F both has already occurred. So E and F, E intersection F. So in short form we can write this formula, probability of E, F, G. Their order is important. So probability of E into probability of F when E has already occurred into probability of G when E and F both have already occurred. So this is the multiplication rule for 3 events. Now we can understand this thing with the help of one example. Example number 8 from your XII textbook. An earth contains 10 black and 5 white balls. Black ball is here 10 and white ball is 5. 2 balls are drawn from the earth, one after the other without replacement. What is the probability that both drawn balls are black? So there are 15 balls and 2 balls are drawn one after the other without replacement. So what is the probability that both balls are black? We have to assume here event, suppose event A is first drawn ball is black. First drawn ball is black. Second B, second drawn ball is black. Drawn ball is black. Then we have to find probability of A intersection B, because both the event should occur simultaneously. According to multiplication rule, probability of A into probability of B when A has already occurred. Now we have to find probability of A. That means first ball should be black. The favorable number of outcomes is here 10 because 10 balls are black and total number of outcomes will be 15 into. Now B, event B should occur under the condition. So B is again second ball is black. It is given that first drawn ball is black. The first ball we have drawn that is black. So number of black ball will be here 9. 9 and total number of ball will be 14. Here without replacement. So this is the answer 90 by 15. You can 15 into 14. You can cancel this and then by 2, 3, 7. So 3 by 7. So in this question we have applied multiplication rule for 2 events. Now next question number, example number 5, example number 9. These questions are given in your NCERT book. So you can see the question there. Question number 9 is here. 3 cards are drawn successively without replacement from a pack of 52 well shuffled cards. 52 cards and we have to draw 3 cards. Probability first 2 cards are king and the third card drawn is an S. So again here we have to assume 3 events, that A, the event first drawn card is king. First drawn card is king. Now event B, assume that second drawn card is king. Now third card should be an S. So third card should be an S. So we have to find the probability of A intersection B intersection C. That is, we will apply a multiplication rule for 3 events. This can be written as in this way also: A, B, C. This is equal to probability of A into probability of B when A has already occurred into probability of C when A and B both has already occurred. Now probability of A, that means first drawn ball is king. So there are 52 cards. So sample space number, sample points are 52, and favorable number of outcomes will be how many black cards are there. Sorry, how many king are there? 4. So 4 kings and total number of cards 52. Now for second drawn should be also king. It is given that first drawn was king. So number of king cards is here 3, and total number of cards is 51. Now see, third card should be an S. So number of S card is here 4, and total number of card one card will reduce, so it will be 50. So this is the answer of this question. So in this way you have to apply multiplication rule. Next topic is independent events. Independent events. Two events, suppose E and F are two events associated with sample space S. Then E and F are called independent if occurrence of one doesn't affect occurrence of other. That means probability of E oblique F is equal to probability of E, provided probability of F should not be equal to 0. So occurrence of probability of event E doesn't affect the occurrence of event F, and probability of F oblique E is equal to probability of F, where probability of E is not equal to 0. So this is if this condition, if any two events satisfy these two conditions, then we can say E and F are independent. Then E and F are independent. Or in another way, we can define independent events, suppose by multiplication rule, probability of E intersection F is equal to probability of E into probability of F oblique E. Here F E is F. So probability of E into probability of F. Or you can write this probability of F oblique probability of E. Both are same, so no need to write. So this is the required condition for to prove two events are independent or not. So in short form we can write probability of E F is equal to probability of E and probability of F. So this is the required condition for probability for independent events in two events. Now for three events, probability of E intersection F intersection G. For three events E, F and G, it should be probability of E into probability of F into probability of G. If any three events satisfy this condition, we can say events are independent. If it is given events are independent, then we can apply this formula for finding unknown things. Now come to question from your exercise. Question is here. Let E and F be events with question number 6 from your exercise. Exercise is 13.2. Let E and F are two events with probability of E is given here 0.3, 0.3 and 0.6. Now here we have to check whether E and F are independent or not. Where E and F are independent or not. Question number 6 is this. That was question number 11. That also I have written here. Question number 6 is let E and F be two events with probability 3 by 5 and 3 by 10. And probability of E intersection F is 1 by 5. Are E and F independent? So E and F to be independent, how do we solve this? E and F to be independent is probability of E intersection F is equal to probability of E into probability of F. Just we have to prove this, then the events can be independent, otherwise not independent. So left hand side is given 1 by 5. First you have to find right hand side P, E and P, F. So P, E into P, F. This is right hand side. This is equal to 3 by 5. 3 by 5 into 3 by 10. 3 by 10 is equal to 9 by 50. 9 by 50. And left hand side, that is probability of E intersection F is 1 by 5. So this is not equal. You can write here, then that says probability of E intersection F is not equal to probability of E into probability of F. Therefore, E and F are not independent. For independent, simply we find this result. Okay. Now, question number 11. From the same exercise 13.2, question number 11 is given two independent events A and B such that probability of A is this and B is this. We have to find probability of A and B. So first part of this question, probability of A and B. That means both the events should occur simultaneously. That means A intersection B we have to find. And since A and B are independent, so we can apply this formula PA into PB. Reason we can give in bracket says A and B are independent. So value are given 0.3 into 0.6 is equal to 0.18. Now part 2 of the same question, probability of A and not B. Probability of A and not B. That means probability of A and B dash, not B, that means B dash. That is equal to probability of A intersection B dash. So one important note you can write down: if A and B are independent, if A and B are independent, then first one A dash and B are independent. Second one, A dash and B dash are independent. So this thing we will apply here. A and B are independent, then A and B dash will be also independent. So probability of A into probability of B dash. Reason says A and B dash are independent. Now here put the value. Probability of A is given 0.3 and probability of B dash 1 minus probability of B, that is 0.6. So this is 0.4 and 12, so 0.12. Now third part of this question, probability of A or B. A or B is equal to probability of A union. We use union for or, for A we use intersection. So by the formula, probability of A plus probability of B minus probability of A intersection B. So probability of A is 0.3 plus 0.6 and minus, this is again A and B are independent, so we can write probability of A into probability of B. Now this is 0.9 minus probability of A is here 0.3. 0.3 and probability of B is here 0.6. So 0.90 minus 0.18. So it is equal to 0.72. Fourth part, P neither A nor B. neither A nor B. That means probability of neither A, that means A dash intersection B dash. This we have to find. So by applying formula A dash into probability of B dash, the result we can give here, since A and B are independent, so A dash and B dash will be also independent. A dash and B dash are also independent. Now put the value B A dash, 1 minus 0.3. So 1 minus 0.3 and B dash 1 minus 0.6. Here we are applying this formula P A plus P A dash is equal to 1. So here this is 0.7 into 0.4 is equal to 0.28. Now question number 12. 12 is here. A dice tossed 3 times. Dice. Find the probability of getting an odd number at least once. So 3 times one dice tossed, and you know the occurrence in second toss doesn't affected by occurrence of first. So this experiment or tossing is independent of each other. So here you can define some event that A is the event odd number occur in first toss. Odd number occur in first toss. In first toss, B is odd number occur in second toss. Second toss, C is odd number occurs in third toss. So we have to get at least once odd number. That means A or B, A or B or C. Odd number either in first toss or in second toss or in third toss. So for all we apply union, probability of A union B union C is equal to, by formula, probability of A plus probability of B C minus A intersection B minus B intersection C minus C intersection A, and is plus sign probability of A intersection B intersection C. Since A, B, C are independent according to the experiment, so what is the probability that in first toss we get odd number? So PA, we can write here probability of A, odd number in first toss. So 3 by 6, that is 1 by 2. Now probability of B, odd number in second toss. Second toss is independent from first toss. So here also 3 by 6, that is 1 by 2. Similarly, in third toss odd numbers should occur. Then again 3 by 6, because all three are independent. 1 by 2. So PA is 1 by 2 plus 1 by 2 plus 1 by 2, and now A intersection B, which can be written as A PA into PB, since A and B are independent, minus PB into PC minus PC into PA, and plus sign PA, PB, and PC. The reason you can write here says A, B, and C are independent. Now we have value for each. This is 3 by 2, and again minus 1 by 2 and into 1 by 2. So it will 1 by 4 and minus 1 by 4. So minus 1 by 4, minus 1 by 4, 3 times minus 1 by 4, and plus 1 by 2 plus into 1 by 2 into 1 by 2. So 3 by 2 and minus 3 by 4. 3 by 4 plus 1 by 8. And so 8. 4, 3 are 12, and